Hi guys, and welcome to this Manufacturing for Educational series on Voltera PCB 3D printer. I'm just going to wait a short while for the last few people to join and then we'll get started. Perfect. Now once we've had that, we'll get started. Okay, so I just want to give you a quick introduction to the Manufacturing for Education series. Last week we did an episode on Wazer, which is a desktop waterjet cutter. We then also looked at a Voltera PCB printer, which is what we're going to look at today. And then next week we've got the Pocket NC, which is a desktop 5-axis CNC printer. So if you've not signed up to the Pocket NC one next week, feel free to drop me an email. You get my email at the end of the webinar, and then also you can drop me an email if you did miss the Wazer desktop waterjet cutter. We can send that to you so you can watch that back. Brilliant. So just quickly to run over the agenda for today, we're going to have a quick introduction. We're going to look at why does Voltera exist, an overview of existing production methods for PCBs, the Voltera for Education, how it's been used, and then we're also going to have a sneak peek at the Voltera's new products that's aimed at sort of more advanced research and development. And that is top secret, so we do ask that you don't share any of that that is shared in this presentation with you. And then I'll also talk you through the pricing and the support that is on offer from purchasing a Voltera through SolidPrint 3D. So without further ado, I'm going to hand over to our colleagues at Voltera, and they're going to talk you through a bit more about the Voltera products.
Welcome. Thank you all for joining today. Just want to first say thank you for taking the time out of your busy schedules to listen and hear more about Voltera, the V-One, and our upcoming product, Nova, to help accelerate some of your electronic needs and some of your electronic projects. So let's get started. So imagine this, you're coming off of a school year and you're looking for new ways to challenge your students, to engage your students a little bit more. You want to develop that need for them to want to learn about the basics of electronics and electronic design and fabrication, and not only just for them, but for their own professional career, for them personally, but you don't necessarily have the tools to do the job. And you guys are already familiar with breadboards, and breadboards are great to begin with, but they're still missing that other part of electronic design within the CAD software, within the component selection, within the footprint design of the actual circuit itself. And those are the skills, and that's the gap that we're looking to close to ensure students are industry ready. So at Voltera, we've developed additive technologies to open those opportunities up for students. So how do we take our students to go from traditional electronics to flexible hybrid electronics, or FHE for short? And that's sort of the gap we're also looking to close on, is expanding their horizons and the opportunities that they're able to design and to innovate, and to essentially arm them for that next level of design and electronics and technology. And it all starts with the hardware. Every piece of technology that you interact with every day, your cameras, your laptops, your phones, there are PCBs within them. And traditionally, PCBs have been made using subtractive methods like chemical etching. But those types of methods aren't easy to bring to the classroom, onto the desk, and for the students. So there are three main prototyping methods today. So number one is chemical etching. Number two, a subtractive method using milling technology. And number three, outsourcing it overseas, outsourcing and sending your designs overseas to have mass manufactured. All three work, don't get me wrong, but those are three options that are hard to bring into the classroom, hard to bring onto the student's desk just for safety and health and timing reasons. So yes, we can ship our designs to a manufacturer overseas, but school terms are short, and that time with a student is very short as well, whether you're teaching secondary or post-secondary level students. The iteration process is slow, and this is actually the time where you want students to iterate quickly so they can absorb the mistakes, they can understand where they went wrong, and design better. And again, we're missing that hands-on experience. We're missing that practical experience gained during this process without having a hands-on tool or the tool to help foster that. So what are our alternatives? And this is where the V-One comes in, because it's an all-in-one tool that allows your students to print PCBs right on their desktop. I'm going to play a quick video with my colleague Katerina, one of the co-founders of Voltera, who just walks through the printing process of the V-One.
Hi everyone, I'm Kat, co-founder at Voltera, and today I'm going to be showing you how to make a double-sided circuit board with the V-One. So step one is to upload your design files. You could use any software you're comfortable with, just upload them into Gerber format. You'll see the toolpath is already calculated when you upload your design. So next, clamp down the sacrificial layer and the board. I'm using an FR1 board because we're going to be drilling into it. So once that's secured, snap in the proximity probe. It will be used to generate an accurate map of the surface. So once that's done, go ahead, snap in the drill head and fire it up. Now the board has been mapped in XYZ space, so the drill knows exactly where to go. If you're going to be using different hole sizes, the software will prompt you to change the drill bit after the current hole size. All right, let's print some traces. So swap out the drill head for the ink dispenser, let it calibrate, and begin laying down conductive ink. If you find a mistake on the board, you could easily reprint it using selective printing. This is a great feature for design modification and rework. Okay, so now it's time to cure this board. Simply remove the sacrificial layer, flip the board, and rest it on the baking ledges of the clamps. Curing takes about 40 minutes, and you're going to want to let it cool down after, so I'm going to go grab a snack, and I'll be right back. Okay, so that looks good to me. Now I'm just going to flip the board back over so that we can print and cure the bottom side. Okay, so our traces are printed and cured onto both sides. Now I'm just going to go pop in some rivets and use the riveting tool to secure them into place. Okay, with that done, we can clamp the board back onto the printer and go ahead, snap in the solder paste dispenser so that we can get some solder onto these pads. And with that done, I'm just going to pop some components onto here and watch them reflow directly onto the heated bed. This board does have a few through-hole components, so I'm going to go solder them using the provided solder wire. I'm using plenty of flux, and my iron is set to 200 degrees Celsius because the traces are heat sensitive. Okay, so let's see if my punk console works. Okay, so this is an example of a very simple circuit. Thank you all so much for watching. We can't wait to see what you create with your V1.
And these are just a couple case studies in South Korea and in Ethiopia where these institutions are bringing global focus towards STEM curriculums, especially for educating today's students around the world that may not have this type of technology easily accessible to them. And this is just a couple pieces of evidence that we found and from our current users for exactly that. Just to continue on the South Korea undergraduate program, these are students that have a V1 on every student's desk. And not only are they learning electronics, but they're gaining that hands-on industrial relevant experience through product design, through application design, entrepreneurship, mechanical design, things like that. And I'll talk about our friend here, the green robot, in a little bit more detail in the later slide. So a couple of projects here. The first one, very simple, the V1 printed LED array PCB, which is enclosed in a 3D printed box, and you can see the pattern that's printed once you turn it on. There's also this kind of multi-complexity, multi-board system that contains an LED counter, revolvers, and different sequence PCBs in them. And these are all part of an advanced engineering curriculum where almost every single level or every single step unlocks a new, more complex design skill, theory, and system design. And students were tasked with building something from home. So things like fans, lamps, music boxes, clocks, these were all on display for students and were created by students. And so why only design PCBs when you can actually make fully functioning products and pair the Voltera V-One with a 3D printer? These are the types of projects that engage and challenge our students to ensure that they're having fun, they're learning, they're team building and socializing, as well as fostering that creativity. This green robot is actually voted Voltera's favorite student design project. This is actually a voice-controlled robot that you can ask him to walk, you can ask him to sit, and you can ask him to dance. And this was actually designed by a 17-year-old student where they were able to develop skills in not only electrical but mechanical design, software and firmware programming. And they were able to do this all with the V-One and 3D printers. So there are so many engineering concepts, so many skills learned throughout the several weeks that they use the V-One and they use the 3D printers. And this is a Toronto startup called Octify, where they were developing productivity boosting smart glasses. So these smart glasses were meant to detect distractions, give you personalized coaching through a phone app, for example, give you that real-time feedback. And they raised $200,000 successfully on Indiegogo. And they were able to use the V-One in conjunction with 3D printers to develop the initial prototypes of the Octify specs. To summarize the V-One feature set, so you can print circuitry based off of the Gerber file design that you've created. We dispense that conductive ink into that file design, and we can dispense it down to a minimum trace width of 200 microns. You're able to solder paste dispense, so you can dispense onto both printed and prefabricated PCBs and down to a pin-to-pin pitch of 0.5 millimeters. And as well, you can reflow using the V-One with the 550 watt integrated heat bed, which means you can solder your joints of the components directly to the conductive traces that we've printed in the previous step. And we've made the V-One as simple as possible to use, so it's really plug and play. There's only a couple cables that you'll need, so a USB to your computer and a power cable to power on the machine. Very minimal maintenance required other than cleaning out the calibration switches pre and post print. And there's magnetically swappable heads for each tool. So for the probe, for the dispenser, for the drill attachment, you just swap those in and out. Along with very easy to use hardware, we made sure that our software is UX friendly. So it is a Gerber input. It's free to use, continually updated. Video instructions on how to print and what to look out for as you print your circuit, as well as in-app support. So if you ever need a helping hand, we are here, and Solid Print is here to help. And some key reminders here with the V1: we close the skill gap with the students. We give the students the challenge, the engagement that they need to ensure that they're ready for industry. We're giving them that hands-on experience with the V1. We make it simple to use, very easy to use, a plug-and-play system like I mentioned before with the hardware and the software. And we're really fostering that growth mindset within the students. We encourage them to fail. We encourage them to learn from their mistakes, because that develops that growth mindset, that develops the skills and the grit that they need to move forward.
Thanks, Roy. That was an amazing presentation. Really enjoyed that. I definitely learned a few bits about Voltera, and it's great to know about the new product. I'm sure that's a lot of hard work that's paid off there. So I just want to quickly go through the pricing of the Voltera One that's currently on the market. As I said, that there is a launch coming for the new Voltera product in October, so stay tuned for that. So there is two models that we currently, or two versions that we sell. The Voltera One with the drill attachment, and then the one without that. These are the prices for one unit. We do offer some discounts for multiple unit purchases, but I do just ask if you get in contact with us, and we can look at getting a setup that's suitable for you and your educational institution, and we can look at a pricing that's sort of appropriate for that. But just to go over what is included with the standard Voltera One, so there's two different conductive cartridges. So there's the conductive one and the solder paste cartridge. There's different substrate sizes included, as you can see in the image there. There's a set of disposable nozzles. There's a Hello World starter kit, so a quick little introductive project. There's some solder wire, there's a rivet kit, and there's a few more extra little bits and pieces just to help get you off the ground. If you did want to see what is exactly in a Voltera One, we do have an unboxing video on our website and YouTube channel, so you can head over there and have a quick look at that. Just like to touch on the support and guidance that SolidPrint 3D will give you. We do offer on-site installation and training, whether that be for your engineers or your technicians. So we'll come on site, we'll get you set up with your Voltera or Volteras, and we'll talk you through how to use them and get the most out of them. We can then also offer, we'll offer sort of ongoing technical support. So if you do have any questions, you can reach out to us via phone or email to our in-house team of engineers who are very knowledgeable and are more than happy to help. For any of you that have purchased 3D printers or any other products from us, you'll know sort of how good the team is on the technical support side. And then finally, I'd like to showcase a little project that one of our engineers has worked on. He's turned one of the Hello World kits into a little rocket. So that's the free sample that we're giving away for attending this webinar. So if you'd like to get your hands on one of those, feel free to just drop me an email. My email is just there on the screen. And then, yeah, without further ado, I'd like to hand over to questions. As I say, we've got Roy on the call as well, who'll be able to help from Voltera. So yeah, feel free to ask either myself or Roy any questions that you might have. Thanks very much, and I'll see you next week for the Pocket & See webinar. Cheers.